few different objectives for today. I can use order of operations with fractions, which we've done before. We can solve equations with fractions, which I don't know that we've done that necessarily. And then I can solve rectangular and triangular applications of fractions, and then I can solve fraction word problems. So quite a bit of stuff here. It's applications of fractions, of course, but in addition to all the fraction stuff, we're going to be seeing the negatives involved as well. But like we've seen with all four of our basic operations, when we have negatives, we just want to determine if the answer is a positive or negative, and then we perform the operation as though there were no negatives, kind of thing. All right, so order of operations stuff. This order of operations stuff with PEMDAS, it's not always PEMDAS, is kind of the main point that I like to make here. So PEMDAS, it's not always PEMDAS. Okay. Now the reason that is because you do have parentheses, that's the P. You do have exponents, which is the E, but it's the multiplication. It's these key words right here with the ors for both multiplication or division, and then last of all, addition or subtraction. So it's not just multiplication first and then division, or addition and then subtraction. What we do is we look for the operations going from left to right, and if one of the two occurs to the left, then we have to do that one first. So if division occurs first, we have to do it, and then if multiplication happens to the right, then it has to occur second. So you'll see this commonly on exams, where they'll do something just like this. They'll do like a 12 divided by 3 times 4. And what they're looking to see is if you'll do this part first. Because if you do, you've thrown things off pretty badly. Because you cannot do this multiplication before you do this division, because the division occurs to the left. Okay, so that's the third part, multiplication or division, but the same is true for addition and subtraction. So again, on an exam, you can expect, and again, I'm not saying that they're going to put all these on an exam, but they generally do, put one or two of them. They'll say, do 5 minus 1 plus 7. Okay, and then people do, 1 plus 7 is 8. Okay, and again, this is bad, and this one is bad, because for the same reason as the multiplication or division, addition or subtraction has to occur. If the first one to the left is the one that you have to do first. You'd have to do 5 minus 1 first. Like up here, you'd have to do 12 divided by 3 first. Okay? So be very careful. Take your time. If you need to have these 4 steps out so that you can remember, especially with parts 3 and 4 here, and just take your time and look and think, okay, maybe I should do the multiplication or division first, or maybe I should do the division first. Yeah, that's because it's happening further to the left. And again, same thing with addition or subtraction. Another tricky type of problem that you're going to see, because this happens often as well, is they're going to give you a set of parentheses like this. Now, we know we have to do parentheses first, and that's great. So they may have something just like 7 plus 3 right here. But what they'll do is they'll do 6 minus 2 right here. And what'll happen is students, again, this is an error, but they'll do 6 minus 2 first. Okay, well that means you were doing that subtraction. Even if you did the parentheses right here, you may do that before the parentheses, but what happens is there's multiplication between the 2 and the parentheses. You would have to do that before the subtraction as well. So on a problem like this one, on an exam, if I were to see something like that, it's just all the credit's gone, no matter what, because you've done something that's way out of order, right? You should have done the parentheses first, then you should have done the multiplication, and then you should have done the subtraction. Again, I'm pointing out very common errors that students make so that hopefully we know what we may need to fix right now. My last class, what I told them is it's kind of like if you were going in for an operation, like for a broken leg, for example. Sorry, I couldn't help it. So if you had surgery or something like that, you would want the doctor to perform the operation in a specific order, right? And by the way, I don't have any clue how operations actually work. But I'm just pointing out, I assume there's a specific order they're going to do things in, right? Like you don't want the doctor to put his gloves on and then wash his hands. I mean, that sounds weird altogether, right? Or it's like, Maybe we should cut the patient open and then we'll give them the anesthetic, right? I don't want that. So it's the same idea. If we can learn how to operate on math problems, I guess we become math surgeons, but that sounds kind of nerdy. Here's this one. We got a few different operations here. You got, well, I'm going to say you got an exponent, you got addition, and then we got multiplication. One of the key features of a problem like this one, which we've seen already, is this part right here. That portion, this part right here, reads 3 times 2/3. And I'm saying that because that's not a mixed number, and that's one of the mistakes that people make right here. It's a mixed number, but it's not a mixed number. All right, because we're used to, especially in the fractions unit, which we are in, just with signed fractions, we're used to seeing, well, that's a mixed number right there, 3 times 3 plus 2. And then we have a mixed number. No, that's not what we're looking at right there. This is 3 times 2 to the power 2. I'll start that over. It's 3 times 2/3. Okay, so we need to be careful on those. That is not a mixed number. Once you see the parentheses, you know it's a separate, well, now a factor from the 3. It is not part of a mixed number. Okay, so if you guys saw this, what's the first thing we would have to do? Very good. Now here's another thing that I'm gonna do. Do you have to do this? You do not. But I'm gonna put it there because I don't want to forget how this works. I'm gonna put that negative right there. I'm gonna make it a -1. Okay, so it's like the 3. It's being multiplied by the 2/3. I want to see this as -1 times the 2/3 to the power of 2. Okay, now again, do you have to do that? You do not. But we definitely need to do that exponent first. But the nice thing about the exponent and having this -1, in my opinion, is that it means I'm not getting the negative mixed up with the exponent because it is not part of the exponent. If I were to look at these two factors right here, there's only one negative, but some people would say there's two, but there's only one negative, yeah, because of the negative on the outside of the parentheses. So that means, and here's the great thing about the order of operations, is that I can focus on one part of the problem at a time and ignore the rest of it until I actually perform whatever operation that I'm focused on. So I'm just looking at the 2/3 to the power of 2, and that's all I'm going to do. I'm going to take that 2/3 to the power of 2 and multiply it by itself. There's 2 of them. I don't care about the -1 on the outside that I put in purple. I don't care about the +2 times 2/3. I don't care about that stuff right now. I will, just not right now. So what I have from here is just fraction multiplication, which I will do. So I've got 2 times 2 in this fraction, which would be my new numerator is 4. And in the denominator, I've got 3 times 3, which is 9er. Okay, so I've got 4/9. You're welcome to put that in parentheses if you'd like. I'm not going to do it, but yeah. Now that I've performed that operation, I want to see the rest of it, right? So I've got the -1 times that 4/9, and then we still got that all plus the 3 times 2/3 like this. So this is my new expression, and we may say, well, did that really simplify it? I'll let you decide. But it's going to make my operations a lot more direct. Okay? So in the beginning, you could say there was even parentheses right there, but that's not really anything to do with the parentheses, especially since we haven't covered decimals yet. But after parentheses, then we have exponents, which we did right here. I don't see any other exponents in the problem, especially this one right here, which means I'm going directly to multiplication or division. Now again, there's no division, there's only multiplication. In fact, there's 2 sets of multiplication. We have this one here, and then we got this one right here. That second one wasn't showing, which it doesn't have to, but I'm going to put it there just so that we can see. Yeah, we got to do some multiplication. So I will next perform this multiplication right here, -1 times 4/9. And to make this a little bit easier for me, I don't know if it's easier for you, but for me, I'm going to make that -1 over 1. Just so I know that I'm actually multiplying 2 fractions, right? Okay, well that'd be, I'm going to deal with the negative first. I've got a negative times a positive, or there's only one negative, or there's an even number of negative, there's an odd number. Negatives counting's hard. Which means my answer will be a negative. Then I'm going to have a fraction. I'm going to multiply the numerators. 1 times 4 is 4. And the denominator, 1 times 9 is 9. Some of you may have knew that was going to happen without all this work. That'd be okay if you did, because you know that 1 times anything is the same thing, right? Anything times 1 is itself. I did a little extra work, and that's okay, but now I'm going to put this extra step in here, although you wouldn't necessarily need to. So I'm going to show this, and I'm going to give myself a little bit more space, but now we're going to multiply these. And to multiply them, I'm going to show this as 3 over 1. Correct. Very good. So in this, we see that the 3's can simplify each other. So I'm going to do 3 divided by 3, and then 3 divided by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. And now the multiplication, in my opinion, is going to be a lot easier. So I've got 1 times 2 in the numerator, which is 2. 1 times 1 in the denominator is 1. Now I'm going to keep that 1 just because I'm dealing with fractions, right? And we got the first fraction, we got negative 4/9 plus that 2 over 1. Since we are adding these two fractions, I need the denominators to match, which I will force to happen. So I know 9's a multiple of 1. Anything's a multiple of 1. So I'm just going to multiply the denominator and numerator by 9, which is going to make this fraction now 18 over 9. So there's that 9 denominator, right? We wanted that. So I've got negative 4/9 plus 18/9. And like I said, I'm going to show this step, even though not all students do. So I know I have only 9th size pieces, and we are adding the number of those 9th size pieces. We got negative 4 of them. Then we've got 18 of them added together. And when I add these together, I will still have some number of 9ths. Just how many is there going to be? Well, they're opposites, and there's more positives than negatives, so I know my answer will be a positive. But then we take the big number, 18, and they're opposites, so I'm going to subtract the small number 4. 8 minus 4 in the 1's place value is 4, and then we drop the 1, positive 14/9. Now, they did not ask for a mixed number specifically, but because I'm a math nerd, I'm still going to show it. So you could have put or 1 and 5/9. Now again, does it matter which one you put? I don't think it does. But some people like one more than the other, and it's up to you which one you do. Okay, what do we got? 7/9 minus quantity 1/3 plus 4/5. Take a minute, try this one out. See how you do. All right, so we got simplify, and we got the parentheses, which we must do first, because parentheses are always first in the order of operations. Now be careful, because some people, like, we get used to what they call distribution, which we've done before already in this course, but not in this semester specifically, but in this course. Once we see parentheses, we get used to kind of just distributing, but here there's no variable, so I would say there's no need for distribution, okay? So that means we are going to, in fact, take the 1/3 and add it to the 4/5. The problem right now is that the denominators don't match. But I can make those denominators of 15 pretty quick, right? And this is actually kind of just the old-fashioned method. Take this first denominator, multiply it by the second one, denominator and numerator. So that'd give us 12 over 15. And then take the second denominator, 5, and multiply it into the first fraction, denominator and numerator, which will give us a new fraction of 1 times 5 is 5, 3 times 5, matching denominator is 15. Now, notice I'm not even putting the parentheses around this, because I don't care about the rest of the stuff. I do care about the parentheses because that told me to do this part first, but the rest of it I don't care about. I'm going to come back to it later, just as we have already done. So, with the denominator 15, I'm going to keep the denominator 15 because that's the sizes of the pieces. It told us to add the two values together of 5 and 12. Now, from what I could tell, it seemed like everyone had this part. So 5 plus 12, which I will show. 5 plus 12. 5 plus 2 is 7. Drop the 1, 17. We got 17/15. Of course, that's in parentheses there. And now we've got 7/9 minus 17/15. So yeah, because we are subtracting, absolutely we need a common denominator, just like we did with the addition above that was in the parentheses. And even right now, I'm going to take away the parentheses because I don't need them. I'm just subtracting that 17/15. If it was negative, I would keep them, but then I would change the minus negative into a plus anyways. Okay, so I've got 7/9 plus 17/15. You guys already used the denominator of 45ths, right? So that means you'd have to multiply the 15 by 3, so the 17 by 3 as well. Let's just focus on that first fraction. So 15 times 3, again, we're going to show that this is going to be 45. 5 times 3 is 15, carry the 1. 3 times 1 is 3, but add the 1 is 4, so 45. That's our new denominator. But then we've got to do 17 times 3. It's not a great 7, but 7 times 3 is 21, carry the 2. 3 times 1 is 3, but add the 2, makes that 5. So 51 45ths from the 17/15. Now we'll look at that 7/9, and we're going to multiply the 9. We got to multiply that by 5 to make that denominator a 45. And that's one of our multiplication facts that we should have memorized. Same with 7 times 5, which is 35. And we're going to need to subtract these. The great news now that we have that is that the denominators match. So we know we're dealing with 45th size pieces. We're subtracting. What are we subtracting? Well, 35 minus 51. Now, some people like to change this into an addition problem, which you can if you'd like. I'm not going to, though. I'm going to keep this in 45ths. And we'll do 35 minus 51. Okay, so we're subtracting. We're starting with 35. We're taking away more than what we start with, the 51. 35 minus 51, which means that our answer is definitely going to be a negative. So I'm going to put my negative sign in there. Okay, now, how far into the negatives would it be? Well, we're just going to take the big number, 51, and then we're going to subtract the 35. And that will tell us how far into the negatives we've gone. So we're going to make that 11, minus 5 is 6, 4 minus 3 is 1. We get negative 16 45ths. 16 is divisible by 2. So I'm just checking, I'm making my last check. Can we simplify that? 16 is divisible by 4 and 2 and 8 and 16. 45 is not divisible by any of those. So we are done. So complex fractions, just one or more fractions inside of a fraction. And complex fractions are kind of tragic because in time they've destroyed many lives, kind of like regular fractions have. Fractions already have the power to destroy. But when you start putting fractions inside of other fractions, they tend to have the power to demolish. You know what I'm saying? Like it's destruction on a new level. However, like we've already seen, if we know how to divide with fractions, which really means we just multiply, then what happens is we change this complex fraction, which is a fraction divided by another fraction, or just something divided by a fraction. Somewhere here's a fraction, inside a fraction. Just change it into a division problem, okay? And once you have that in as a division problem, then you can change that division into multiplication, right? So even on this problem, we could take this one step further. Even though it's abstract, you'd say, well, I know that first fraction is going to stay the same, but I'm going to change that division into multiplication, and then I'm going to flip or reciprocate that second fraction into a D over C situation. And then you can do straight multiplication right there. Now, we'll have to keep in mind, if we have any whole values, either as the numerator or denominator, just make it over 1. So that if you need to flip it, then you can, or if you just need to operate with it with the multiplication, then you can. Here's another way that I've seen students do it. Okay, so what they'll do is they'll look at it like this, and what they'll do is they know they're going to make a fraction out of this. Okay, so, but here's how it works. Now again, do I care which way you do it? I don't. So you get to decide which way you like to do it best. Some people say it's related to FOIL, but I don't like that either. So what they'll do is they'll do the outer parts, the A and the D, and that becomes your new numerator, A times D. And then they'll multiply the inner parts as well, B and C, so B times C. And you see what happens is we kind of skipped this step here, this one, and just kind of went straight to this part right here. Okay, so if these were numbers, you can do this directly with this. I don't know. There's lots of rainbow math stuff like distribution and now this, but there's not really a formal name that I'm aware of for this. Well, whatever. I'm going to show this one twice with both methods. Okay, so now again, the first thing I would recommend is just taking this and just changing it into a regular division problem, okay? So that means your numerator here, which is 12/25, that's gonna be your dividend. And then the 4/5 here is gonna be your divisor. That's the second value in a division problem like this. But now that we have that, right, we don't want division with fractions. What we want is multiplication. So I'm gonna take that division, change it to multiplication, and reciprocate or flip that second fraction into 5/4. Of course, the 12/25 remains the same. Okay, with this, right, we took this division problem and just showed it kind of as old-fashioned division, not long division, just with an old division sign. Change that into multiplication by reciprocating that second fraction. Now we're ready to simplify the problem, the fractions, right? So I'd look at the 12 and 4. They're both divisible by 4. Correct. Yep, so 12 divided by 4 is 3. 4 divided by 4 is 1. Oh, yes. Yeah, I think you're one step ahead of me there. 5 and 25 are both divisible by 5. Okay, so 5 divided by 5 is 1. 25 divided by 5 is 5. And now we are ready for multiplication.
Final answer is just 3/5.
Correct. So 3 times 1 in the numerator is 3. 5 times 1 in the denominator is 5. 3/5, done. Okay, so how does that differ from that other method? It doesn't, it just kind of shows the work just a little bit differently, in my opinion. That's what I would say. So we're going to do the second part, but I'm going to show it with that the rainbow thing, okay? So I'm expecting some kind of fraction out of this. And then I'd show, well, you take the outer parts, you got the 12 and the 5, which you're going to multiply. And then you got the inner parts here with the 25 and 4. 25 times 4. And what do you know? You end up with exactly the same thing we did there, where you would simplify this. Again, I just kind of skipped the work there, but 5 and 1 again. So you end up with 3/5 anyway. So however you do it, you're going to end up with the same answer. And that's good. That's what we want. 3/5 or 3/5. Same answer. Now, if you make a mistake trying this one out, that's okay. Right? Make your mistakes right now. That's a good time. This is not a test. We can make mistakes right now. So do it, try it, and we'll go over it. I'm going to start with the numerator right here, which means right now I'm ignoring the denominator. Sometimes what I'll do is I'll even cover it up like this, just so I don't have to worry about it being there. It is there. I'll come back to it. I just don't care about it right now. So I'm going to focus just on the numerator, 2/3 plus 1/2. And what I want is the denominators to match. So I will. I'm going to force them to match. So I'm going to take the 3. I'm going to use a denominator of 6, right? So I'm expecting is to be 6 sixths and 6, which we're going to be adding together. That's our operation. So I'm going to take the 3 and make it a 6 by multiplying it by 2. And then the numerator 2 also multiplied by 2 makes it a 4. The 1/2, the 2 denominator, I'd have to multiply by 3. So the numerator 1 times 3 makes that 3/6. Now again, I can't emphasize this enough. The 4/6 and the 3/6 have the same exact value as the original fraction. So all we did is change the way that it looks. That's it. But now that those denominators match, we're ready to combine the numerators because we're dealing in sixths, which we're adding together. 4 plus 3 of the sixths, which is going to give us a fraction in sixths. That'd be 7 of the sixths. Now that's as far as I can take that right now, right? I got my fraction. It's just fully simplified with the addition part right there, which means now I need to go to the denominator. So let's get rid of that box. Okay. What you'll notice, and this happens from time to time on the assignment as well, the 2/3 and the 1/2, it's the same 2/3 and 1/2. It's just the operation changed. So where I had 4/6, I still have 4/6 from the 2/3.
Doing minus instead.
That's correct. And instead of 1/2, I've got 3/6, but now it's subtract. So dealing in sixths once again, we would have 4 minus the 3 of the sixths, which in sixths, 4 minus 3 is 1.
So now it's just 7/6 divided by 1/6.
That's correct. And
As usual, if you keep change flip.
oh yeah, so some people like that keep change flip business.
That's what Stephanie called it.
Yeah. And so now to do that, I like to change it first into that division stuff. So I'm going to show the
Yeah,
division.
horizontally.
Yes. Yeah, horizontally, right? Because it was vertical, now it's horizontal. 7/6 divided by 1/6, like this. And now we're ready to change that division into multiplication by reciprocating the second fraction into 6/1. We have 7/6 times 6/1, and the 6 and the 6, well, they're both divisible by 6.
So just 1 on both sides.
That's correct. So 6 divided by 6 is 1. 6 divided by 6 is 1. And now we're ready. This should be pretty well simplified right here, although I'll show it a second way. But in the numerator, 7 times 1 is 7. In the denominator, 1 times 1 is 1. And we've said this before, if you ever have divide by 1 like we do here, just simplify and show it as a 7 by itself. So, like we said in the objectives, we got rectangles and triangles, so opposite sides are exactly the same. That's the nice thing about rectangles. And then the area is found by taking the length and multiplying the width. So this is multiplication, and since we're dealing with fractions, we're expecting fraction multiplication on this. I don't remember seeing any perimeter problems, which is where you add all 4 of the sides together. So you take length plus width plus length plus width, and then you add them together. But again, on the assignment, I only saw area type problems. Now, when you do area type problems, you need to make sure that your units are squared. So if your length, let's say your length here was in feet, then your width would of course be in feet. Then what you want is feet squared, which you can write like this, or I think you may have seen me wrote it as square feet like this. And it doesn't matter which one you put.
For the answer?
Yeah, for your units on the answer. Now, what you cannot do, especially on an exam, is just put feet and then don't really emphasize the 2 right there. Because I think that's a dot. You know what I'm saying? So make sure it's squared. Or, worst case scenario, you didn't show anything right there. You know what I'm saying? So it's definitely not feet. It's not feet. It has to be square feet, feet squared. And that's just with feet, right? So if it was yards, yards squared, square yards, meters, square meters, or meter squared kind of stuff. All right, our favorite word problems. An interior designer is redecorating a room that is 22 1/4 feet long by 17 1/2 feet wide by 10 feet high. Now that's already sounding like it's a volume problem. Let's continue. At one end of the room is a door that is 6 feet 6 inches high and 4 feet wide. Oh, they had to go 6 feet 6 inches, huh? One of the walls contains 2 windows, each of which is 2 feet wide by 2 feet 6 inches high. What is the area of the floor in square feet? How much will it cost to add hardwood to the floor if it is installed for $8 a square foot? Okay. So, especially the feet and inches thing, I didn't expect to see that because that's we shouldn't see that until I think it's module 7 or 8, whatever. But the good news is that the inches stuff has to do with the walls, right? So you got a door, and then you got some windows. Those are on walls. All it's asking for us for is floor stuff, not wall stuff. So the windows and the door don't matter at all to us, not at all, okay? Now, if they did, we'd have to draw those in, and a picture would be very nice for this, but we don't really need it, okay? But since it is asking for the area of the floor, we got 3 different dimensions. We've got length, width, and height. Now, in a floor plan, and I'm not like an expert on this stuff, I'm just a math nerd, but on a floor plan, what you would want is width and length, not the height. The height is, well, I don't know, the height, it's how tall the room is, right? But the tallness of the room is the walls, and that's not floor stuff. That is not floor space. And we don't even care about the ceiling stuff, right? So when it talks about the floor, we are dealing with the 22 1/4 feet long by 17 1/2 feet wide. The 10 feet high would be applicable for the walls, which would include the door and the windows, which we don't want and don't care about right now. So that's what we want. We got the area of the floor. Area is found by taking length, just like we saw from that last slide, length times the width.
Normally I just write L times W.
Yes, but I'm a math nerd, so I went the distance there and wrote the whole thing. In fact, if you wanted to put width times length, it really doesn't matter. It's the same thing, right? Because that's the commutative property of multiplication. So my length is going to be 22 1/4 times the width, which is 17 1/2. Well, I'm sure you've noticed already, but that's not enough room for me to work. So I'm going to take all that information and I'm going to put it up here. And then I'm going to do the work. Okay, well, we're ready to start operating here, right? But first, I'm sorry, we're not ready to operate. We need these as improper fractions. And it says, what's the area of the floor in square feet? It didn't say that it needs the answer as a mixed number, but I'm going to show it as a mixed number one way or the other. So, first off, what I'm going to do is I'm going to take that 22 1/4 and I'm going to change it into an improper fraction. Of course, we're dealing in fourths here. So that'd be 22 times, well, I better do this differently. 22 times 4. 4 times 2 is 8. 4 times 2 is 8. So that's 88, but plus the numerator 1 makes that 89 fourths. Okay, so 22 1/4 is exactly the same as 89 fourths, assuming I did my math correct, which I don't always do. But now I need to change the 17 1/2 into an improper fraction as well. So again, the denominator will not change, but I will take my 17 and multiply it by 2. 7 times 2 is 14, carry the 1. 2 times 1 is 2, but add the 1 makes that 3. So we got 34 halves, and we are multiplying these. Okay, well, it looks like we can do some simplification with the 34. Nope, it's not 34. I forgot to add. Boom. See what I mean? All right, so that's, yeah, we gotta add that numerator 1 in there. 34 plus 1 is 35. Try not to make the same mistakes I do. Hopefully we can learn from them anyways. Okay, well, that changes everything because I don't see any simplification that can occur right here. None. Not the 89 2, not the 35 4, none of it. Okay, well, that means we got a lot of multiplication here. The good news is that I got, in the denominator, I've got 4 times 2. Well, that's easy enough. That's 8. But one that I struggle with to do in my head is 89 times 35. So I'm going to show that. 89 times 35. Let's see what we get. So 5 times 9 would be 45. Carry the 4. 5 times 8 is 40, but add the 4 would make that 44. See, I almost made another mistake. I almost had 45 right there. Now that we're in the tens place value with the 3, so there's no 1s. 3 times 9 is 27. Carry the 2. 3 times 8 is 24, but add the 2 makes that 26. So now we're going to add those. 5 plus 0 is 5. 4 plus 7 is 11. 1 plus 4 is 5. Plus 6 is 11. Carry the 1. 1 plus 2 is 3. So we got 3,115 eighths. Now I'm going to label this because it's a legitimate answer. So with that, again, this is a legitimate answer, so I'm going to put it was in feet, right? So this is actually an area of feet squared. And that would be one of our answers. That's not simplifiable, and that's okay. But the next thing I'm going to do is show this answer as a mixed number, which means I would have to take the let's see if I can do this, 3,115, and I'd have to actually divide it by 8. So 8 won't go into 3, but it will go into 31. Thank you. 3 times. 3 times 8 is 24. So I'll make that 11 minus 4 is 7. Drop the 1. So 8 goes into 71. Should be 8 times. 8 times 8 is 64. So again, 11 minus 4 is 7 again. Drop the next value, 5. 8 goes into 75 9 times. 9 times 8 is 72. That gives us a remainder of 3. Okay, with that, now, so we have our first answer. We had the 3,115 eighths square feet. But now we have the mixed number as, 389 And again, this is gonna be in eighths, but it's 3/8 in square feet. And again, it doesn't really matter which one you put in for this specific answer, but do be aware on the assignment and on exams, they may specify that they want the mixed number, which is why we've shown both. So part B, yeah, that was a lot of work, and that's part A. But part B now, how much will it cost to add hardwood to the floor if it is installed for $8 a square foot? Now, of course, we're not putting anything else in there, like the padding they put underneath, and I don't think you need nails for this kind of stuff, but whatever. Okay, so what we're gonna do is just figure out the cost of just the hardwood floor, which is $8 a square foot. Now that $8 a square foot, it's gonna be pretty handy for us, because going back to the improper fraction, which is the one that I want, because remember, if we were gonna operate with the mixed number, we generally change it back into an improper fraction anyway. So I'm gonna operate
What it is.
with that 3,115 eighths. I don't want to use cycle method on this number. We already had it, right? So let's just use it. Okay, now it's $8 for every square feet. This is how many square feet there are. So that means that what we would do is take that $8 a square feet. We're just going to multiply this by 8. Now the good news is we're going to show this as 8 over 1. And what do you know? 8 and 8 are both divisible by 8. That's convenient. 8 divided by 8 is 1. 8 divided by 8 is 1. And now, when we multiply these, we will have the direct cost. I'm not worried about the 1 over 1, but I will do 3,115 times 1, which is 3,115. In dollars, done. Okay, so this second part made it, after all this work, it's like, oh crap, they're going to make us do the same amount of work. It wasn't that bad, especially with this being 8. Now, keep in mind, if it was 2, then we would have to simplify here, then you'd get 4, and then you have to do a little bit more long division kind of stuff. But this one worked out pretty nice without being 8. All right, triangle's an area. So a perimeter of triangle, of course, you just take all 3 sides and add them together. But now that we're looking at the area of a triangle, you got 1/2 times base times height. Now, some students worry about this, like, how do we get that on there? What happens is they make a parallelogram out of this, and you can make fun of my drawings because I suck. But in any case, it's just half of a parallelogram, which is another way to say rectangle. I know that's a funky looking rectangle, but don't worry about why it works. Just understand that it's half of that, okay? And if you wanted to find the height or the area of that parallelogram, you'd take the base times the height. So the height of the rectangle goes from the base up to one of the corners of the triangle. And what you'll see, sometimes they'll put this on there, but they'll put this little box right here, and that indicates that it's created a 90-degree angle with that dashed or dotted line. Is it going to be dashed or dotted? I can't guarantee because I don't remember on the assignment, but it's going to look something like what you see right here. Those are the 2 values you need. You need this one here, the dashed or dotted line, and then you need the line that creates a 90-degree angle with. Sometimes what they'll do, and you got to be careful with this as well, they'll say, look at this dashed line right here, and they'll say, look at this one right here. This length is X inches or something. We don't care about that purple value because, well, what they might do is just not give you this part either. Okay, so of the 3 values, and they may give you all values, they may say, look at this one, it's 10 feet. I don't know what they're going to do. Maybe this one's 12 inches. I don't know. But the one we care about is the base and then the height. Those are the only 2 we care about in this formula, which we have up here. The B, of course. Hopefully this is fairly logical. But the B is for base, and the H there is for the height. Now, the height is generally a dashed line that goes through the triangle like this. But what you'll see sometimes, let me see if I can do this with technology. Yeah, so what they'll do is they'll draw a triangle like this, and what happens is that it creates a 90-degree angle here, and so they're not actually going to show a line that goes through the triangle. So it's this 90-degree angle business that's going to tell you the height. So for this specific rectangle, this I would consider the height, and then this length right here would be the base. So they didn't give us, they're not writing down any of the values for us, but we can find these values, okay? On this triangle, I can see from this tip right here down, I'm gonna make this kind of a, well, it's poorly dashed or dotted line, but that's gonna create a 90-degree angle with this side length, which I'm gonna call the base. Okay, so I do have a height and a base, and going back to the formula, it's 1/2 times the base times the height. Yeah, there's all multiplication. So the base, we can figure out this length because it's just the length between these two values, and I'm just going to count the boxes. 1, 2, 3, 4. So my base length in this case is 4. Now some students say, well, that base isn't on the bottom. Well, it's just turned. That's all. Okay, so just understand you may have to look at it like this with the base. The base isn't always necessarily what we would consider the bottom of the shape. Now I counted boxes. Some students like to count lines, so they'd say that starts at 0, 1, 2, 3, and then 4. It doesn't matter which one you do, you just need to get 4 for your base. Because some students would say it's 3 because it's a 1, 2, 3. It's not 3, it's 4. Okay, now we've got the height. So again, I'm going to count boxes. So that's 1, 2, 3, 4, 5, 6, 7, 8 boxes. So my height is 8 boxes. We're going to call those units, I guess, because we don't know if this is inches or centimeters or whatever. But again, you could count lines. So you'd start here at 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, again, it's just that you need to get an 8 somewhere in there. And we are going to multiply this all by 1/2. Now I put it specifically like this so that we can look to simplify some of the fractions, which we can do. So let's simplify. We got a 4 and a 2, which are both divisible by 2. You could have divided the 8 by 2 as well, but don't do both the 4 and the 8. So 4 divided by 2 is 2. 2 divided by 2 is 1. And now I'm ready to simplify this fraction. The denominator is the easiest because 1 times 1 is 1, times 1 is 1. In the numerator, 1 times 2 is 2, times 8 is 16. So again, I'm going to write this just as 16. But 16 is not, well, it is good enough, I guess, for this one. Because they didn't tell us what the units are, but if you want to be really nerdy about it, you can put units, you can put it in units squared like this, or
I'm just gonna put inches.
you can put 16 square units. So perimeter, just add all the side lengths together. So we've seen this already with triangles and rectangles in, geez, I think it was model 2. I guess it's more of an equation thing, kind of. Okay, so this one, it says, we've given you a perimeter of this triangle, which is 23 1/4 feet. Notice it's not feet squared, because that's area. Perimeter is just a regular length in feet in this case. And we're going to find the length of that missing side. Now, what would happen is we would usually add all 3 sides together, but we only have 2 sides to add together. So that's what we're going to do. We're going to take the 8 1/2 feet and the 5 2/4 feet, which is, yeah, you may not have noticed, but the 2/4 can be simplified into 1/2. Okay, so we're adding these 2 fractions together. Now, there's other stuff, right? There's other information. We'll get there. But these are the 2 sides that we're going to add together that we know, the 2 sides that we know of the triangle. So let's change these into improper fractions. Again, the 8 1/2, it's still going to be in halves. But we'd have 8 times 2, which is 16. I'm not going to forget this time. I'm going to add the numerator. 6 plus 1 is 7. Drop the 1. So that's 17 over 2. Now the 5/4, of course, that's going to be in fourths. So we're going to do 5 times 4 plus 2. So 5 times 4 is 20. Now add the numerator 2. 0 plus 2 is 2. Drop the 2. 22 fourths. Okay, so this, we're going to add these together. Now, again, if you notice that the 22 fourths can be simplified, you can. But I'm going to pretend like we didn't notice that, because not everyone does, and that's okay too. But I know that 4 is a multiple of 2, so I'm going to multiply the 2 by 2 to make it a 4. So I'll have to multiply the 17 by 2 as well. The denominator will be a 4, which is part of the plan. We planned that. We're going to force that to happen. But then I've got a 17 times the 2. 2 times 7 is 14. Carry the 1. 2 times 1 is 2, but add the 1 is 3. So that's going to be 34 fourths. 34 fourths plus 4 fourths. We're dealing in fourths now. and we're going to be adding 34 and 22. And this will tell us how many fourths there are. So how many fourths is that? Well, it's 34 plus a 22. 4 plus 2 is 6. 3 plus 2 is 5. Yeah, 56. Okay, and I'm going to keep that 56 fourths, okay? And that's in feet. That's not the perimeter of our triangle. That's just these two side lengths. What we want is this one. But as of right now, we have 56 fourths, but we also have 23 and a fourth. So that would be all three of them together. So I'm going to take that 23 fourths feet, which is my perimeter. Let's do this down here. And we're going to change that into an improper fraction. So let's change this into an improper fraction. So that, yeah, it's going to be in fourths for sure. But that'd be 23 first times 4. I should stack that to multiply. 4 times 3 is 12. Carry the 1. 4 times 2 is 8, but plus the 1 is 9. I almost forgot the 1 again. I need to add the 1. 2 plus 1 is 3, 93. So the perimeter is 93 fourths. The two sides make up 56 of the fourths. So we're going to take that perimeter as an improper fraction, 93 fourths, and we're going to take away the two sides that we know, which we already know is 56 fourths. So if you had simplified the 1/2 or the fourths in the beginning, then you would have had halves. You would have had to scale it up into 56 fourths anyways, because we need common denominators to subtract. But now that the denominators are the same, so we're going to make this in fourths by subtracting 93 and 56. This will tell us how many fourths there are. So 93 minus 56. So make that a 13 minus 6, 7. 8 minus 5 is 3. 37 fourths. Okay, so that is the length of our missing side. We're going to label that in feet. Okay, and that's our improper fraction. Or if you want to change it into a mixed number, well, we'd have to do 37 divided by 4. 4 doesn't go into 3, but it goes into 37 9 times. There's a different color here. 9 times 4 is 36. When we subtract, 7 minus 6 is 1. That's our remainder. So you could have said it was 9 and 1/4 feet as well. Either one of these. All right, if we're going to solve multi-step equations, multi being more than one operation is needed, which we should see on the assignment, but also the exam probably, then we need these principles of equality. Now, we've seen this already where we need some distribution and combining like terms. Isolating the variable will include these two principles of equality, and then forcing the coefficient to be 1. That's usually just division, but we have seen examples which require multiplication as well. These principles of equality for our 4 basic operations are in, they're the only 4 operations that we should need. There are more principles of equality, but they get a little funky once you get out of the 4 basic operations. But principles of equality are they're pretty much saying whatever you do to one side of the equal sign, you must do to the other side. So in the past, this is the way that I like to look at it. So let's say that you had 5 and then it was equal to 5. Okay, the question happens with the equal sign right there. That is a question mark. Is that true or false? Well, 5 does equal 5. That is a true statement. If I were to change this just a little bit, even just a little bit, and made it 5 equals 4, now it is a false statement. But if I make that a 4 plus 1, I've returned it into a true statement. Okay? Now the reason why that's important is because the 4 plus 1 doesn't look like 5, but it is 5, right? And what they'll do, even beyond that, which we've seen already, they'll say, look, 4 plus something is 5. Well, we just saw that the only value that would make this true is if you replace the x with a 1. In fact, there's only one value that would make this true, but there's an infinite number of values that make it false. We want only true statements, okay? So if you started, let's do a different example. So that was one example. Okay, so if you started with, oh crap, let's say 10. Okay, so if I said 10 equals 7 plus, well, let's just use 10. Okay, so this is a true statement right here. But if I say, you know what, I'm going to take 10 plus 1 right here, I've made it false unless I do the same thing to the other side like this. Okay, so that's what these are saying. I used addition here, but the same would be true for subtraction and multiplication and division, so long as your subtraction and division are the same, right? You can't use commutative like I've shown here. So whatever you do to one side, you must do to the other side. What you'll see when I do these is that I will show a line through the equal sign like this, which brings my equal sign down. And then I'll be like, you know, minus 10 and minus 10, both sides, something like this. Okay, then this maintains truthfulness because whatever I do to one side, minus 10, I did to the other side, minus 10 as well. But again, the same thing is true for multiplication and division stuff. So when we're going to make a zero, which we will be doing, you need to use either addition or subtraction to make zeros. Okay, but in truthfulness, the equations that we're going to be solving, all we're trying to do is make zeros or ones. In this case, zeros, right? You use addition and subtraction to make zeros, which means if you see addition or subtraction, you should expect to make zeros. And that's the first thing you're going to do because between the four operations, because that's how we will isolate the variable. We're going to make values zeros because if we can make them zeros, we get to ignore them, just like we would people that are zeros. You know what I'm saying? So I know that's jacked up, but that's one way that we can kind of remember it. Now, addition and subtraction is to make zeros. The fourth part here is to force the coefficient to be 1. That's where we use either multiplication or division. This is where we make ones, but not just any values are we going to make ones. It's specifically the coefficient. And for those of you that forgot what the coefficient is the number being multiplied by the letter. So if you have an x, let's say you had like a 7x, let's make it a negative even. If this was my variable x, the coefficient is negative 7. The x is not part of the coefficient. Okay? So that's important to remember because if it asks for a coefficient, you put the x in there minus points. Only the negative 7 is a coefficient. If you see something that's just an x, like this, then the coefficient is what we would call a phantom 1, which we've seen already. We've seen an example that was kind of like this, but what they did is instead of it being like 1/4 x, they did like a question mark over 4 kind of stuff. And then they said, make all the denominators the same, and then you can operate with just the numerators. I don't like that strategy because it opens us up to make lots of mistakes. And students in the past, when they've tried it on exams, especially finals, they make the same mistakes, and then it sucks because you can't redo finals, you know what I'm saying? Excuse me. So I'm going to stick with order of operations on here, which means that I'm going to stick with just operating with the fractions. So with solving equations, the first thing we would do is distribution, which would require parentheses. We shouldn't see parentheses yet. Okay, so I shouldn't expect to see parentheses. Then you would do combining like terms. Now, the 5 and the 1/5 are like terms because they don't have x's. The x does. The problem is they are across from each other through the equal sign. And the equal sign is a very powerful symbol in mathematics because you can't just operate over the equal sign. And that's where principles of equality come in. So that's what we're going to do next. Okay, so again, there's no distribution, no combining like terms on either side of the equal sign, which means we're going into isolating the variable. Isolating the variable means that the variable right here is x. What I'm going to do is I'm going to take it, and I would like it to be just by itself. Right now, it's showing us 1/4 x, the x's, plus the 1/5. I don't want the plus 1/5 right there, okay? So what does that mean? That means I'm going to make it a 0. We're trying to make that 1/5 a 0. And the good news about making values 0, especially this term is considered a positive because of the plus sign. If I wanted to make that a 0, I would make it minus 1/5. Okay, now I put that minus 1/5 there in red, which means if I do it to one side, and that's what the line is for through the equal sign, I know I need to do it to the other side as well. Now notice I put the minus 1/5 here with the 5 horizontally. And that's because I need to operate right here. So I'm going to show the 5 as 5 over 1. Let's make that a little bigger there. Okay, and I need common denominators in order to do that subtraction. But the good news is that the 1/4 x, which I've already dropped, can drop, and the 1/5 plus 1/5 is a 0. Do I need to put the plus 0 there? I don't, because that's what we made it a 0 for. Okay, so the one denominator with the 5 would have to be multiplied by 5. So the 5 also multiplied by 5 makes that 25/5. And we're going to minus the 1 of the fifths. So how many fifths is that? 25 minus 1 would be 24 of the fifths. Next up, we have 1/4 as our coefficient of x. Now on the last slide, we showed we want the coefficient of x to be a phantom 1. The problem is, right now it's a 1/4. Stinking 1/4. So what we're going to do is we're going to take 1/4 and make it a 1. Now, the 1/4 is being multiplied by the x. How do I make a 1/4 a 1? As it turns out, how do you make anything a 1? You just divide it by itself. 1/4 divided by 1/4 is 1. Now again, that purple divided by 1/4, I put it there, which means I need to show it on the right side as well. Divide by 1/4, which again I'm putting in horizontally. 1/4 divided by 1/4. There's my 1 right there. I've slanted it to cross it out as a 1, but I'm showing the 1 right here, and that's okay if you do on an exam as well. But that's going to tell me what x is. One of the x's would be. And at this point, we got the 24/5. I'm going to change that division into multiplication by flipping or reciprocating the 1/4 into 4 1s. Okay, so I don't see any simplification that can occur, but I know the denominator is going to be a 5. What I need then is a 24 times a 4. So 4 times 4 is 16. Carry the 1. 4 times 2 is 8, but add the 1 makes that 9. So 96/5. And as much as you want, I'm not going to change that into a mixed number.
We don't have to.
You don't have to. No, especially on equations like this one where it says solve for x. I don't even go that extra step because, again, you're going to open yourself up to make some mistakes. So that is it. That is all for this one. It is done. Now, again, going back, we made a 0. We made a 1. That's all you got to do. All right, now the last thing I'll say about this example, let's make this a little bigger, is if this 1/4 were negative, then you would have divided by a negative 1/4. All that would do is change the answer to a negative. It wouldn't change the numbers at all because, again, with the sign fraction stuff, all we're doing is looking for signs. And once we know the sign of an answer, we're doing the operations directly. So, on this one, right? Again, no distribution needed, no combining like terms. So I'm going to go straight into making zeros, which is really just isolating the variable, which right now is a negative 1/5 x. I would like to have that equal something. I don't want anything added to it like this stinking plus 4/5. So I'm going to have to subtract 4/5. Boom. Now, again, what does that do for us? It makes it 0. And I'll get to that. But first, what I'm going to do is I'm going to take that 2 25ths right here. Let's make it a little bit more math friendly and show this horizontally. So I gotta minus the 4/5 right here. I can't do 4/5 minus the 2/5 because that would make that a negative. It's not negative, it's positive. So minus the 4/5 needs to be over here. Okay, well, the denominators do not match right now for the 2 25ths minus the 4/5, so I'm going to force them to match. So I'm going to multiply the 5 by 5 and the 4 by 5 as well, making that 20 25ths. And it was 2 25ths minus the 20 25ths. So this is going to give me 25ths of some sort. But it's 2 minus 20. We're taking way more than we have. So I know the answer will be a negative. And then I take the big number, 20, and subtract the small one, 2. So make that a 10. Minus 2 is 8. Drop the 1. It ends up being negative 18 25ths. Now, the rest of the problem, going from left to right, we just did the 2 25ths minus 4/5. We dropped the equal sign. we can then drop the negative 1/5, but we showed the minus 4/5 from the 4/5, and that is how we get the 0 right there. Again, there is a plus 0 right there. We just don't want to look at that garbage, so we're not going to. So I got negative 18/25 equals negative 1/5 x. That's our new equation, but it's the same as the old equation. It's just simplified. Now that we have that, what we would like here in the end is just a regular old-fashioned 1x, not a negative 1/5 x. So I'm going to take that negative 1/5 and I'm going to divide it by itself, negative 1/5. And I'm going to take negative 18/25 and also divide it by negative, I know that's kind of sloppy right there, but it's a negative 1/5. Okay, now before I do the division and change it to multiplication, I see two negatives. 1, 2 negatives, which is going to make my answer a positive. That's good, because I don't have to worry about that garbage. And I'm going to change this division into multiplication by flipping the fraction. Again, I don't care about showing the negative anymore. It's just 5/1. And so I've got 18/25 times 5/1. And what do you know? 5 is 25.
My dad's calling.
Yeah, you're good. So the 5 and 25 are both divisible by 5. So that's, we're going to need to do that. 5 divided by 5 is 1. 25 divided by 5 is 5. Okay, so in my numerator, I've got 18 times 1, which is 18. In the denominator, 5 times 1, which is 5. And I get positive 18/5. More of our favorite word problems. So we're going to translate this expression and evaluate, so we're going to solve it as well. So on the assignment, that should mean there's two boxes to fill out. First is the translation, and then the second part is the actual answer or evaluation of what we're doing here. So let's read this. Your gas tank was 1/3 full. When full, it holds 13 gallons of gas. How many gallons of gas were in the tank when it's 1/3 full? Okay, so we got the two values. It's 1/3 full, but it holds 13 gallons of gas. So we're going to take those 13 gallons of gas. That would be full. But unfortunately, right now, you only have 1/3 of a tank. So if you have a full tank and it's only 1/3 full, we're going to multiply these. It's kind of like the multiplication, which I'll kind of color code this, but it's the of part. Kind of. I'm trying to think, maybe I'm guessing 1/3 full. It's 1/3 of a tank, or 13. It's not really that of. I apologize. That's not really correct, but it's 1/3. It's 1/3 full. So we're gonna, yeah, it's multiplication. Now here's the thing. If you divide right here, okay, let's say that you were like, maybe it's division, or maybe it's even like addition or subtraction. You're gonna get a really funky number. Like if you add, you're gonna get 13 1/3. If you divide, you're gonna get 39. Now the label here is gallons, right? If a full tank is 13 gallons, you can't have 39 gallons when it's only 1/3 full. You see, it should be less than 13. So even if you do the wrong operation on these, it should be fairly obvious that you've done something wrong. You need to try a different operation.
So we're going to try and multiply first?
So yeah, well, the multiplication is what it is the correct operation right here. Okay, so with this operation, we're going to do 13/1. There's no simplification that I can see. And so we're going to multiply, right? You got 13 times 1, which is 13. 1 times 3 is 3. Now that's okay for me if you show the improper fraction, because it didn't say it wanted specifically the mixed number, but I'm going to still show the mixed number. So that'd be 13 divided by 3. 3 goes into 13. 4 times 3 is 12. It's a remainder 1. So 13/3 gallons, or 4 1/3 gallons. The same thing. And again, depending on what they asked for specifically will be the one that you want. But since they didn't specify, we're going to show both on this one. When you get to the end here, right, like 13/3, maybe that doesn't sound so good, but like if you took 13 divided by, just 13 divided by 3, 1/3 of it, then it should sound like it's 1/4. But if you added, you'd get something close to 13. If you subtracted, you'd get like 12 2/3. And so just keep in mind, if you do the wrong operation, just think about how the answer applies to the words that it gave you in the beginning, because it should be fairly obvious that you have performed the wrong operation. Only one operation should come out looking like it's correct. So you bought a large bag of cookies at the bakery. You ate 3/8 of the bag, and later you ate 3/7 of a bag. What fraction of the bag did you eat? And what fraction of the bag remains? I worry about people that know that they've ate 3/7 of the bag. But here we are in a math class, okay? See, even the 3/8 are like, what? How do you know? So you guys are gonna try this one out, but as you're trying it, remember, look at your answer. You may need to reread that problem 3 or 4 times to really understand which operation you need to use. But look at your answer and make sure it makes sense in the context. Then we'll go over it. Here's the thing, you're gonna go to this cookie bag. You got a large bag of cookies at the bakery. You're gonna go and you're gonna do the first, you're gonna eat you got a first eating. The first, oh, that sounds bad. The first eating, which is 3/8 of a bag. Then later, you got a second time you're gonna go to this bag and you're gonna eat out of it. There's cookies. That's 3/7. That's what it says right here. Now it says, what fraction of the bag did you eat? Well, that means you're going to take the first and add the second. So we're going to add these two together. Now that we are adding, which means that we need common denominators, so I'm going to take this first fraction and multiply those by the second denominator, 7. So that's going to be 21/56. And the second fraction, we'll multiply these by 8. So 3 times 8 is 24. 7 times 8 is 56, but we are adding these together. So this is going to give us some number of 56, which we are going to add. That's 21 plus 24. So again, this will tell us how many 56ths of the bag we've eaten. So maybe there's 56 cookies in the beginning, I don't know. But in any case, we got 21 plus 24, 4, which is 1 plus 4 is 5, 2 plus 2 is 4. 45/56, and again, just as my label, I'll just put bag. I don't think bags is appropriate, but maybe it is, I don't know. Now that's how much was eaten. That's how much we did eat of the large bag of cookies. But now it says how much remains. Well, there's a full bag that remains, or that we start with. We start with the full bag. We're going to start with 1 because that's a full bag.
All right, that makes sense.
Then we're going to subtract how much we've eaten, which is the 45/56. Now this may be more work than everyone needs, but the 1, instead of 1, I'm going to show it as a full bag as 56/56. Whoops. See, and now we're going to subtract in 56. This will tell us how much is left. 45, 56. Yeah, so it's a 56 minus 45. 6 minus 5 is 1. 5 minus 4 is 1. 11/56. Again, we'll just kind of label this in, I'll just say bag. That's how much remains. That's it. We did it. Have remaining and how much was eaten. And that's it. So we got our 4 objectives. We did order of operations with fractions. We did equations with fractions. We did rectangular and triangular applications with fractions. And then finally, word problems with fractions. And we enjoyed it so much.